Everybody, thanks for joining us. Afternoon, evening, and wherever you are in the world. Just wanted to kind of go over. This is our first webinar. We really wanted to just start, getting the word out there about what Mosaic is and what it does, and more importantly, what our customers have really been, telling us and what we've been seeing through our customers. I think we kind of start with the remote monitoring part, which is the really easy part of what we do. It's the most visible, I guess, and we have a ton of customers that have Mosaic sitting in a number of different sites where they can bring all that data back to them in-house and into one screen. I think one of the best ones we have would be DirecTV, who's been a customer for a long time, and they have a ton of remote sites that we monitor for them. Maybe one of you could tell us a little bit about, kind of the things that we're bringing back from them and how that all works with Mosaic.
Sure, I'll take a stab at that, and David, feel free to jump in. Obviously, we've had a long-standing relationship with DirecTV, or AT&T as they are now, for going on nearly 13 years. So they are obviously one of our biggest customers and one of our best customers that we have out there, but by no means the only one. But the things we're doing for them, it's interesting. We're covering a few different aspects of the system. So we're doing the baseband monitoring. So, obviously they are a uplink provider. They're a satellite provider. So they have about 168 what they call local collection facilities, where they're getting content in from local providers. And that's really the entry point into their network. And we are monitoring every piece of hardware that signal is traversing across from all of those 168 local collection facilities through to their main distribution sites. So they have a couple of major broadcast centers where all of that traffic all the signals are being brought back to. Obviously, we're monitoring the entire equipment chain all the way to the point at which it gets handed off to the RF side. And on the baseband side, it's split into two main factions. They have what they call the local channels, and then the CONUS, or the continental US channels. Right now, they are broadcasting about 4,200 services. And so Mosaic is actively monitoring all of the hardware at the element level. We're talking to managers of managers, to compression systems, which tend to be islands unto themselves, but we're also hooked into those and pulling all of that information back. We're then layering on top of that the service information. So, if device X fails at LCFY, what does that mean? What's the implication of that? What's the impact of that in terms of their services? And we talk a lot about monitoring, but the other side of Mosaic is the control aspect, right? So I don't want to get hooked up too much on monitoring, because there's plenty of platforms that just monitor equipment. But Mosaic goes further than that. So it allows our users, our customers, to then also be proactive in terms of, okay, yes, a piece of equipment has failed. Equipment does that from time to time. There's nothing you can do to avoid it. There's some interesting sides, and I don't want to sort of steer the conversation too far away from your original question, Bill, but you can get into things like predictive analytics. So looking for trends that would predict a failure ahead of it actually failing. So there's a lot of excitement in terms of that area, because if you can prevent a service going off air, that's obviously better than reacting to it after the fact. So there's a lot of investment from our side into those sort of areas. But in addition to that, obviously, if a failure does happen, so we provide them the mechanisms, the tools, the control capability to bypass the faulted equipment and get that service back on air, as quickly as possible. Now, the system can do that manually, and it can do it fully autonomously as well. And it's just a matter of how comfortable customers are with the automation, and tends to be a progression, right? So, when a customer first installs Mosaic, it tends to be more manual. They don't fully trust the system yet. And as they get more confident with the system and know it's making the right decisions, then they transition more to an automated role within it. So for DirecTV, as I said, 4,200 services that are being monitored from point of ingest all the way through to uplink. We do the baseband side and we do the RF side. They separated the systems just for resilience. It's the same software, core software that's running in all instances. But we're also monitoring the RF side. So if you've got a customer that's a satellite uplink, they've got a teleport, then Mosaic is equally adaptable and applicable for those kind of usage as it is for a baseband terrestrial transmitter broadcaster in the same way. So obviously they're a huge customer. They've got a lot of equipment base, different manufacturers, different types. And one of the nice things is we're totally agnostic to the underlying manufacturer or vendor of the equipment. And that gives our customers a lot of power in terms of when they choose new equipment, they can choose it based on its technical merits, not because it happens to fall into the control system that they're using. So it gives them a lot of capability around that as well. So, they're obviously a big flagship customer for us, but from a technical standpoint, we've got exposure to a large amount of equipment and a lot of different ways of operating that equipment through DirecTV, which has been fantastic.
Sure. And we were talking about the other day, which I thought was really cool, is that obviously remote monitoring and remote control of a lot of those things, whether it be a TV station here in the States that has a transmitter or receiver up on a mountain, or David, you were talking about yesterday or the day before about the Vietnam radio station.
Oh yeah, the Voice of Vietnam. So their sites are incredibly remote, and we work with a hardware integrator there. He sent us pictures of them basically lugging hardware up these hills. 30 guys lugging the hardware up the hills, but you can imagine trying to do monitoring of that. And so that's why, they need a product like Mosaic, because they can't have guys running up the hill, every time the generator, check the fuel level on the generator and things like that. The pictures are really good though. Just the amount of manpower to mount those antennas. But then, we're pulling all that data and, they're in the main city, just, monitoring all their equipment.
Yeah, that's obviously an extreme scenario where you're having to lug stuff up a hill and trying to get up that hill in probably any time of the year is not the easiest. And we have, in a little, more closer to home thing, we have transmitters on top of hills that are, like ski hills, getting up there is not easy as well.
I was thinking Nebraska, sometimes you just can't get there. The roads aren't open during the winter sometimes.
Yeah, it's tough.
And just to add to that, Bill, one of the other things that was an issue for Voice of Vietnam, not just the remoteness of the location, but the bandwidth connections we were dealing with that equipment too. So, a lot of those sites were only connected across 3G modems. And so you have to be very conservative on your bandwidth utilization. That's one of the great features of Mosaic, is the fact that we can tailor how much traffic is on that link based on how fat a pipe you have. So if you're on a 3G or even a 2G connection, we can still make the system work because we can be very tailored and very specific in the information we pull back. So in that case, with those hardware units, we were just able to pull the high level status to say everything's still good at the site, so we don't need to go any further. So we could do some pretty cool stuff around just how much information we're pulling back. And that's true on things if you've got connections through VSAT links and other different technologies in terms of linking it. VSAT links tend to be expensive, so you don't want to be pulling huge amounts of data back all the time. And having the ability to tailor the software to the conditions in which it's being deployed is a huge benefit.
Actually, what's really cool though is the hybrid network. So it's not even tied to a device; it's actually a device instance. So, you have some that you have good internet connectivity, and other, like you said, the VSAT links. And so, just being able to pull what you can and keep your costs down as much as possible.
I think that's a good point. Not everybody has a big fat pipe coming to their door and being able to pull as much information as you can through it. And especially these remote places, having barely cellular, having a touch of it, it makes a lot of sense. And plus it could be really, really expensive as well. That's a great point to make there. So let's talk a little bit about staying on air and some of the reporting that Mosaic has done and really helped customers with. I think, James, you were talking about ITV and we did a little video on that recently. Give us a little bit of the backstory and kind of what happened, and how we've really helped them transition to a much more a better reporting system to them.
So it's an interesting story, right? So this is a major commercial provider out of the UK, and it was an unfortunate event that really triggered them to look at monitoring. So what happened was they have their top grossing show, that the main show that they put out on a Saturday night. It was the finale for that show, and what happened was, obviously, they had a fault, they had a failure that took them off air for 2 hours during that particular finale of their highest grossing show. So obviously, that triggered them to perform an internal review of their systems, and how could it be that they got into the situation that they were off air at such a critical, pivotal moment for such a long time.
Not only that, the way they found out were basically somebody was monitoring their Twitter feed, and there was
exactly
complaints. That is not how you want to find out.
Yeah. So, I mean, the in terms of why it happened and the crux of what's going on, they didn't have the end-to-end visibility that they should have had for a major broadcaster. And that's why we started getting to conversations with them. Obviously, they performed a review, and one of the key elements that came out of that internal review was they need to get a better handle of how their services are going across their delivery network. One of the special challenges in their case is that they were hands off in a lot of the areas. So a third-party company ran the Playout. In the UK, it's a national code and MUX system. So once the signal's handed off to the national code and MUX, they don't have any visibility of it until it arrives at the transmitter, and then they can do off-air receivers at the transmitter, things like that, to gain better visibility. So the crux of the outcome came to the fact that they had this catastrophic event, and this is typical of a lot of customers. A lot of times monitoring and control is an afterthought in a lot of cases. So it's only when something major happens like this, and they have an embarrassing event, or they've been taken off air for a good chunk of time, do they suddenly realize, we need some serious monitoring here and some end-to-end capability. And that's really what they were talking to us about, is telling me, how can we get better visibility? And there was a lot of things we were going in with them for, which is, as David mentioned, the Twitter feed. Not a traditional integration for a monitor control system, but being able to collect stats from a Twitter feed. And if you see a sudden uptick in the number of messages coming in on a Twitter feed, that's an indicator, right? It's not necessarily, a good solid fault indicator you get off a piece of equipment, but it's definitely a trending mechanism that you can use to say, hang on, there may be a problem here. Let's delve a bit deeper into the data. So, it's a very interesting problem in terms of how we were able to sort of put mechanisms in place to get their end-to-end visibility on their network. But also, it just highlights the fact that a lot of times systems like ours, monitoring control, becomes a lot more, it gets a lot more focus on it when things have gone horribly wrong in some event. And you also find that the longer that event has been since it occurred, then you start getting lulled back into that same sense of familiarity, and then the pressure's off a little bit. But, it was amazing just to see how adaptable Mosaic was in that scenario. And the other thing, of course, if you're in a case where, you're handing off signals to a third party, and especially if you've got multiple third parties in the loop, having the reporting aspect and the live alerting to say that there's a problem to start with, and then being able to figure out what the root cause of that is, but also then having the reporting aspect. So you can go back to that third party vendor and say, you know what, you took us off air 3 times last week on these days at these times. It provides them a lot of leverage in terms of going back when they're going to contract negotiations with third parties, anything along those lines that they can use as evidence in order to support their case against those third parties. And it's obviously a benefit to them from that point of view as well.
So James, we get 2 questions of this. I figured that it's kind of applicable now, but the first is, could Mosaic have prevented them from going off air? Obviously, in this case, the answer was kind of no, because they did contract out to everything. But the follow-up was, could we be alerted on a mobile device? And that is truly what they needed. because they needed to basically be able to get on the phone and talk to whoever was responsible. And probably because they don't have end-to-end visibility, they would probably have to call 3 people, but they would at least know immediately and be able then to start, pulling hairs.
They're both great questions. So just to sort of further iterate on the first one, preventing them going off air, well, that very much depends on a case-by-case basis, right? So if it is something that is well categorized and is, we're able to automatically respond to, then the answer could be yes in that scenario. We could have potentially stopped them going off air. I know they've got third-party presence in the mix as well, which causes confusion or a lot of, makes it harder to deal with that. But if you're in control of the equipment, then absolutely we could have prevented that from happening. The other aspect of that is
they could have taken over. We could have taken over another channel or something like that, right, James?
Exactly. Certainly, when you get into the network feeds, because you can take a different circuit. There's redundancy built into the circuit paths anyway. So, there's multiple ways you try and prevent that. If we were in control of the equipment, we could definitely have done that. Now, you can't always prevent every outage, right? That's just not feasible. Equipment's going to fail at the most inopportune moments. It just happens.
And not all equipment can customers afford full redundancy on. So.
Exactly, yeah. And it may not even be equipment fault. So we've definitely had cases before when somebody loads the wrong profile into a MUX, and it takes 20 channels off air. That was not an equipment fault. It was just a personal error, a error, human judgment error that meant that the wrong profile was loaded into that multiplexer. So, it's not just equipment faults. So there's always cases where you can't prevent from going off air. But that example I just talked about was a great one because, once that event has happened and you are in an outage situation, then everybody's in panic mode, right? So they're scrambling to figure out what is the cause of the outage, how can we rectify it, how do we get back on air as quickly as possible. Now, in the case of that multiplexer with the wrong profile, it took them 30 minutes to figure out that was the root cause. Well, it just so happens that we actually were working with them just after that, and we were able to put a mechanism in place that would do root cause analysis. So we already know the topology. We already know the interconnectivity of devices within the broadcast chain. And in this case, we were able to show them that if that happened again, that within about 30 seconds, we'd have told them exactly which multiplexer it was and what the root cause of the issue was. Because what you want to do, you can't always prevent an outage, but what you can do is get that service on air quicker. And the way to do that is to be able to focus the problem down to a very narrow, specific set of things to look at. And from there, obviously, in this case, we do have the control capability of that equipment, and we could have reset the configuration on that multiplex to get them back on air quicker.
Yeah, I guess then that's a good point, because we can also monitor configuration, and if it changes and it's an unexpected change, we actually could have either alerted or automatically, pulled back the previous profile.
Yeah, I mean, exactly. Even if because we don't know at that point, whether it was an error that could have been intentional in terms of changing the profile on the MUX, but we would have identified it from a root cause analysis that was the principal cause, because we look at all the downstream outages and go, okay, all 20 services were tied to the same MUX. That's your point of reference there. But also just alerting on the fact that the config did not match what we were expecting would have given them 2 great pieces of information to be able to fix that problem in no time, and not the 30 minutes it took.
Awesome. I mean, and that's really the big benefit is that, we're monitoring all the time. And at least in those situations that you're talking about, if we have the ability to know things that are going on over time, there's a possibility that we could have discovered something before that channel had gone off the air and alerted them, as you were saying before, preventative maintenance as opposed to reactionary maintenance, right?
That's a great example. So there's so many times that, let's say you do have redundancy built into your delivery chain. Well, if you have to fail over to a piece of equipment that's in the backup path, how do you know that equipment's in the right state? How do you know it's in a good place to be? That could be faulted out just like your primary. So having that 20, end-to-end, both primary and backup path being monitored all the time and being alerted, so that, if you have to make those decisions, whether the system makes them or a user makes them, you still need all the information at your fingertips to say, yeah, it's okay to fail over to a different path here, because you could fail over for a minor issue and then take an outage because of it, because there's some equipment in the backup chain that's not working correctly. So being able to give you that entire picture is obviously an important thing. And the same on the RF world, right? So if you've got site diversity, so Mosaic fully supports uplink power control and site diversity across multiple antenna systems. Well, if your backup antenna, you get weather coming through on your primary antenna, and you've got to fail over to your backup antenna. Well, how do you know the weather conditions are better at the backup site? I mean, we have a live map that tells you weather information, so you know that. And we're also monitoring all the fade levels and everything, and also the equipment at the remote site. So, you can make intelligent decisions of when to switch or if to switch based on the information that's being collected across the entire network.
That's a great point. I was actually talking with one of our current customers about them. They've gone through a lot of phases with us already. They've done Playout. They've done some other stuff internally to monitor the remote sites. And one of the fourth phase that he was talking about doing, and this works perfectly into this because it's something that I did when I was still in television years ago, was OB trucks, remote trucks type stuff. And it's like when you're an EIC sitting in the truck and you're pulling all this stuff together. And of course, there's thousands of moving parts every single day up until you turn off the truck, right? And one of the things we were discussing is there's no way as an EIC that you can be monitoring every single one of those points that are going on. And if you had Mosaic, and this is the whole reason he's putting Mosaic in his OB truck, is so now he has the ability to see, what's going on over time, what's going on in that truck. Because you never know. I mean, I've had, guys running cables down across driveways, and in the middle of the night, a dump truck comes in and is doing some work, or there's a garbage truck that comes in is picking up trash. Well, you roll a 2-ton truck over a cable, sometimes issues happen. And how would you know that if it's 12 a.m. and you're sleeping and you get back the next day and everything still looks fine? But you can sit there, and it takes their focus away from dealing with things that you can't normally see on a day-to-day basis, or even at midnight, or whatever it happens to be. And it was a great point that he made that says, this allows my EIC to do other work, building cables, helping out people, not worrying about his transmission lines, about his video and audio lines, or any of that are laying across the ground or in water, whatever it happens to be. It was amazing to me, because that is some thought that I had for years, and especially after I've joined NMNC, I was like, this changes the game for those guys.
Oh, we're working with a prospective new customer, the exact same issue. They have a whole fleet of OB trucks, and when they get there to site and plug in, they spend the first 8 hours, debugging fiber lines, and they constantly have to call back. Can you hear me now? And with Mosaic, they'll be on the truck. They can see what connectivity they have. They don't have to start pinging individual lines and things like that.
It's also another good point. Pushing into OB trucks and production environments is traditionally it's a new boundary for us in terms of monitoring control, right? I mean, these are forward-thinking people that are deciding this is actually a good place to put additional monitoring control. And on the truck side, you've also got the ability. So when they come on, if they move the truck to a different venue, a different sport, whatever they're using that truck for at that moment in time, they can come in and they can reconfigure the entire truck in no time with a system like Mosaic, because they can provision all the services, they can set all the cross points on the router, load up profiles on the vision mixers, and all of the other things that would normally take a good chunk of time before they go live on that event. They can do that readily and easily with Mosaic, at least get it into the 99 percentile range, and then they can go through and make all their checks and make sure everything's set up correctly.
It's how quick they can get set up, things that don't have to be manual anymore.
And it also speaks to the sort of dynamic nature of our system, right? Because, with those trucks, and also with that prospective customer you were talking about, David, we've got nodes popping in and out based on, when they power up a truck. I mean, we've got to then respond to that and dynamically add all of the equipment that's associated with that particular, whether it's an OB truck or whether it's a cabinet at a venue site. When that fiber line comes up, we have to respond to that, and we have to dynamically populate our system to make sure that we are adequately monitoring and able to control all that equipment at that location. So it's a great example of just how dynamic, and it also speaks when we get into sort of the OTT realm when services are being spun up and spun down. It's the same principle, right? So there's a lot of dynamic nature to the system.
We had a question, James, and actually is perfect for this. How difficult is it to add devices? Do you need to contact MNC to add devices to the system?
If you need to contact us, we've done our job wrong. To add devices to the system is very, very simple. And it's more than just, adding instances, right? So, with any system like ours, then there is something, we call it a driver, but effectively it's a protocol adapter. It's a chunk of logic that is doing the conversion between what protocol the device speaks, whether it be serial, whether it be SNMP, whether it's REST, whether it's web service, a SOAP interface, whether it's TCP/IP-based protocols. It doesn't matter. We speak all external protocols, but
we even speak protocols to devices that don't have a protocol. So devices that just have a web page, we can scrape data from that.
Exactly. So, the driver is responsible for doing that collation of data, and all it does is it then converts it into an internal format that we use within the system. Now, we supply standard drivers for most protocols anyway. So adding devices is super easy within the system, but it goes further than that. Our customers, when we deliver a system, have the exact same development tools that we have internally. So our customers, if it's an SNMP device, if they have the MIB for the device, it takes maybe 30 minutes to flesh out all the monitoring points that you want from that MIB, define the control points that you want, what things do you want to be able to control on the device, and tweak some polling configuration. How frequently do you want to, touch that device to get information back, or if it sends unsolicited information to us, how do you want to handle those traps and informers coming back from the device? So an SNMP device is a great story because it takes, it can take as little as 10 minutes or it can take an hour. It's a small chunk of time and anybody can do it. Anybody can load up the MIB, choose the data points that they want. The most frustrating thing with SNMP is the manufacturer's naming of the monitoring points and command control points within the MIBs can be somewhat esoteric. So, having to decode that is probably the hardest thing. The actual building of a driver is so easy, anybody can do it. But we also, if you get outside the SNMP realm, now more and more devices are talking more RESTful interfaces, more modern protocols. So we have tools around building interfaces for those as well. So, it's easy, and every customer of ours has the capability to do it. Whether they choose to do it, that's a commercial decision for them. We are more than happy. We have a professional services team in-house. We are more than happy to take on that work to build drivers. The great thing as well, just to mention it, we're going a little bit off topic here, but if you're under an active maintenance agreement with us, every driver that we've ever written for any customer, for any device, is freely available to any of our active maintenance customers. So, a lot of times, if it's a new piece of equipment and you just contact us, say, hey, do you have a driver for this? And we go, yep, there you go. Drop this onto your system and away you go. So there's that element too. So if it's something we've already done for either internally or for another customer, then all of our customers benefit from that, and that's a free of charge service. So there's no cost associated with it.
That's really great. We have a question. Is it possible to split monitoring between regions and companies being monitored, not letting them see the other things being monitored, other companies specifically?
So I'll start with. We obviously have a couple customers like that. I'll start with Nebraska Educational Television. So for them, we're monitoring their transmission uplinks, their satellite uplinks, but also their IT, the infrastructure, their facilities. And so one of the parts of it for the satellite uplink is NET they upload their own, but then they are also the disaster recovery for PBS. And so we've designed the system so they have that company separation where NET actually, certain users can see all of it, including PBS. PBS can only see the PBS portion, but then even within NET, the facilities people cannot see the uplink facilities. They cannot see the transmission equipment. So, we separated that way. And then we just started a program in Australia, which the follow-on to the question was, it's more like a master monitoring center. We just started a program in Australia where it's a company that basically does the management of their terrestrial uplinks, and then each of their customers gets individual views only into their equipment, obviously. So that's, they're rolling out, and it's, a customer may have access to 10 or 11 transmission sites, but then another customer has 5, and that's how, we separate that basically by user preferences and things like that, or user permissions and things like that.
And I think that goes. Sorry, James. So I think that goes into perfectly is, can you customize reporting in that fashion? So only reporting goes to a certain person.
So just going to say, these multi-tenanted systems are becoming more common now. I think, obviously people are selling services and they want to sell a monitoring capability with it.
Sure.
But to your question, yes, absolutely. So obviously every piece of information that's being collected by Mosaic is being archived. And that reporting has a couple of major, good points about it. So not only can you go back and investigate problems or outages that have occurred, we can also do things like FCC compliance reporting or governmental compliance reporting. We have a customer I was talking to the other day, and they spend 6 hours every month generating FCC compliance reports based on information that is already in the system. Well, our reporting engine is completely configurable, and you can build templates to your heart's content. And we can build a template then that pulls all the right information from each of their transmitter sites and builds it into a properly formatted report that can be sent into, in this case, the FCC, but other governmental agencies have the same requirement. So there's a huge element there that we're saving somebody 6 hours every month of time and effort to do that.
Can nice you imagine being the person that drew the short straw to generate that?
I would lose my hair pretty quickly. But the nice thing is you can set the system up so you don't even have to think about it. So we can also schedule it. Last day of each month, generate that report and email it to the relevant agency. But getting back to your original question, which was more about the multi-tenanted side of it as well, because of the data separation and the things that Dave was talking about earlier, we can provide our customers with access to a subset of reports that is applicable to that customer, and they can only access the data that's associated with that. So you can not only have reports that are stylized and specific to a customer, you can also segregate the data that they're able to report on as well. So, once you start getting into that multi-tenanted realm where you've got multiple customers having access to subsections of the system, then, you've got to put a lot of thought into how you segregate the data, but it's all possible within Mosaic.
Well, so one of our customers in Ireland, that's basically, what the entire system does is it's obviously monitoring all the antennas, but then scheduled is weekly, basically performance reports that he has to send out to his end customers. And so it's scheduled, and basically all of his customers get reports for their antennas.
Yeah, and then you don't have to think about it. The system does it automatically, and your customers get the reports on time every time.
So we had another question. Does Mosaic have hardware components, or is it purely software? And I can take this because the one thing I actually know. Yeah, it's purely software. I mean, except for we need to run in a computer of some kind. Yeah, it's 100% software. We do have a lot of drivers to a lot of hardware components. James and David obviously know a ton about what those hardware components are. I know a lot less about that, but it's 100% software, very easily deployable in a lot of different places, as we were talking about in the beginning, where we have lower software versions, or not lower software versions, but less bulky software versions sitting at remote sites.
So the other thing to say on that, I mean, one of the interesting things, there's been obviously a move in recent times to cloud platforms. And it's one of the nice things about Mosaic, because our deployment strategy is pretty flexible. If you want to install on physical hardware, go ahead. If you want to install into a virtualized cluster you still have maintain control of in-house, go ahead. You want to install into cloud providers such as AWS or Azure, go ahead. The system is pretty flexible in terms of how you can deploy it. One of the things that we're actually looking to do in the near future is also support containerization as well, which is a big push that's coming through, and microservices. And we're also not in any way dependent on the platform either. So you can run on Windows, you can run on Linux, you can even run on Mac OS. As some, we have one customer that does that because they're a radio station. They have to run on cool hardware. But yeah, we don't care. I mean, literally, that leaves you open to making the choice that's right for you. If you're okay with Linux, run it on Linux. You've got a great stable platform. Windows servers now are pretty good, but they still require Windows patches all the time. So it's not a stability issue, then you've just got a management issue. But again, if you're a Windows house, go ahead. There's no restriction anymore in terms of you have to deploy on certain hardware. We only support these processors. We only support Linux or Windows. It's not an issue. We're totally agnostic to almost any deployment environment. Now, you've got to have the resources to be able to handle it. But in terms of what you choose, it's down to customer preference.
That's really awesome. I mean, that really helps, when people are looking to deploy, because I know a lot of people don't like Windows because of exactly what you're saying, James, and they want to run on more of a Linux platform or Unix even. It just makes a lot more sense for those, on-air type of systems to really, really get going. We had a question about, do we monitor anything in Playout, Playout servers, Playout software, anything like that? Can we bring that into Mosaic?
Absolutely. So we do monitor Playout systems. We're typically looking for upcoming events, if there's missing media, things like that we fire into the system to. And it actually brings up another interesting point, which is escalating alerts, right? So in Playout, if you're missing media, but you've got 6 hours before it's due to play, that's probably not a major critical alert. When you start getting closer to 1 hour, 30 minutes before play time, you're going to start escalating those alerts as well. So
where is that file?
Exactly. So the nice thing is the system, can be responsive to that when we're talking about Playout, and your media workflows, making sure that everything is timed accordingly so that you don't get to a situation when your Playout server goes, hey, I'm going to play this next, but I don't have this material. So we do play in that arena. And as I say, we've got mechanisms in place to try and make that, as useful to our end customers as possible.
Yeah, and that's it's all about doing a full end-to-end system. I mean, Playout is part of your end-to-end system.
Well, and that's the best point, right? Because we can monitor and do monitor across the entire, playlist. And again, we always like to say it's a single pane of glass for everything that's going on in your station. And I think that's the best description of it, because you do have a million different programs that are working at the same time, right? Playout systems are working. You have a ton of probes from vendor X. You have your, transmitter site that's doing other things. There's environmental things in that transmitter site that you've got to monitor as well. Fuel levels, how cold or how hot is in there. And having, as a director of engineering, I would want to be sitting in front of a screen like this and to say, we have something coming up in like an hour and they haven't done anything about it, but I do see it's over here. So what are they doing? It's a great example of, we have the full touch of your system and you can customize it as much as you want. I think one of the cool things too is that, you talk about, you got to do these government compliance recordings, and part of that has got to be, taking as run logs and pushing them out to, the governments as well, because they have to be able to see what you aired, when you aired it. And then, of course, there's a lot of other things that go along with that. But, having that touch is really, really important, especially with, TV stations here in the States. So let's see, we have a so can we elaborate a little bit on how Mosaic can be used for monitoring RDS and FM services? So
we actually we integrate with a slew of different devices that perform that monitoring. Anytime you get into these kind of areas, there's always a piece of equipment that does a great job in that particular field, and then we are integrated with that piece of equipment that's doing it. So, I know we're monitoring. We got Diva equipment that we're monitoring. We also integrate with Innovonics equipment. And we have a great hardware relationship with the guys up in Canada, Davicom from Comlab, and we have a great working relationship with those guys. They do a lot of very good equipment that can sit at the remote sites, and we call it basically a data aggregator. It pulls all of the serial GPIO, analog, digital status values from the equipment, from the transmitters, from whatever it may be, and then we are fully integrated with it, so we can pull all of that information back and show it in that single pane of glass you were talking about earlier, Bill. So
I'm sorry to interrupt, but I put together a cool system because it kind of ties the Playout and the RDS. Is so they had it's a FM broadcast, and so they have a Playout system that actually has the what the RDS text would be. And so I actually put together a system that actually made sure that the monitor was receiving the same thing, because apparently they, not them, but it's been hacked before, where what was going out was not what was supposed to. And they were also able to say, okay, well, the actual broadcast made it. So they tied the two together that way.
That actually reminds me, I did a similar thing for a commercial radio provider in the UK. They had I don't think it wasn't malicious, but occasionally they had a fault where they left the traffic alert flag up on RDS. And they were also monitoring the same thing to make sure that the content going out was matching what was expected. But again, we put in an alarm, so if the traffic alert was set beyond the duration it was supposed to, or at times when it was not supposed to be enabled, then we would flag that as a inconsistency in the RDS data.
That's so awesome. And one of the big reasons I came to MNC is to see all these pieces and parts coming together. And again, pushing it to the single screen and being able to bring that back in and being able to report it and everything. One question we did have, and let me go find it real quick, is we do root case analysis across that as well, since we're touching everything.
Yeah, I kind of touched on that earlier in terms of, there's two key elements. One is correlation, so looking for patterns in the data coming in, and also root cause analysis. The two kind of go hand in hand. So they are tenets of the system. So the correlation can do a number of things. So let's say you have a device such a multiplexer where it's got a lot of services running through it. And if it faults out, you're going to get a lot of downstream alarms. So one of the things that correlation can do is aggregate all those alarms into a single fault. Because the last thing you want to happen is to be flooded with alarms to the point where you can't discern what is the true alarm through a whole bunch of knock-on symptomatic alarms. So being able to do the correlation and being able to aggregate everything into a single alarm is a very powerful thing in terms of allowing the user to see, what is important at any one time. And on the flip side, you've also got the root cause analysis, right? So, more and more, if you start looking at these hybrid networks, especially when you start moving into the IP realm, you're traversing across IT equipment, you're talking, there's a whole slew of other equipment in the realm that, yes, we can monitor, but they're also traditionally a different department's responsibility. And being able to look at all of the alarms in the system and do that analysis based on we know the topology of the network, we know where the redundancies, we know what devices are connected to which, being able to, as I said earlier, being able to point you to, based on everything we know, the root cause says that it's a 90% probability it's this fault on this device that's causing it. And that's a very powerful feature because too often there's so many, when you don't get one alarm, do you? Let's face it, if anybody's been in a control center, if something goes wrong, it's usually 100 alarms all go off at the same time. And then trying to sort through that information and figure out, okay, what's important and what's not, what's a symptom, what is the root cause of it is a problem. And obviously having those mechanisms to sort through that data and be able to provide our users contextual information, it's 90% probability it's this. If that's not the issue, it's more likely to be, you give it in a ranked hierarchy of probability. Sometimes it's definite. We can tell you 100% this is the fault.
Well, yeah, I mean, so, when we did the post analysis on that time, basically by the devices that were an alarm, we built a display that here's the only device that is in common across all of them. It's got to be this device because the device didn't report an error because the device was happily doing the wrong thing. But
yeah, well, it wasn't faulted, right? Because it was actually doing what it was told to do. It was just told to do the wrong thing. So yeah, those are the kind of things that the root cause analysis engine really becomes a lifesaver in those events because it can quickly identify the true root cause and being able to correlate and suppress those downstream alarms also helps because it helps get rid of some of the false positives that are out there, and so you can focus on the true alarms in the system.
Well, and I think that's a good point because as you both know, my big background is multi-viewers and having big giant screens up in front of me and in front of operators, and they're going off like Christmas trees, and nobody really knows what's going on. So this really brings it down to a granular level and helps focus the engineers and also the on-air staff to really understand what the primary cause of the issue is. Because again, there was one point in time that they wanted to, I had a customer that really wanted to only know when the bug was in and the bug was out. And, across hundreds of channels, you need to know that across it, but you never know. I mean, it could be that it was in for a little bit or too long or whatever it was, but it just becomes unmanageable when you're looking at, 12 screens that are, 55 inches each, and they have 100 pips on each one of them, or in this case, it was 16 on each one of them. But that's still a lot of flashing lights in your face without actually knowing what's really going on.
I mean, that's a whole different subject, right? We could spend another hour talking about all those things, especially when we talk about, monitoring by exception, especially when you get to the bigger customers, have a lot more services. You need to start changing your paradigm. And that probably would be a good conversation for another webinar. But, there's so many more things that we could talk about along, how monitoring has evolved and control has evolved over the last, 10, 15 years. It's amazing now that there's a lot more technology, there's machine learning coming in. There's as we talked about root cause analysis, you can do things that I'm sure users wanted to do 10, 15 years ago. Just the technology wasn't there.
Absolutely.
It's now coming online, which is good.
Well, listen, we're coming to the top of the hour, so I'd like to thank both David Allen and James Bloomfield for taking the time today to kind of give a big push on what we do and how we do it. You can contact any one of us. There's contact details in the chat. If nobody has any more questions, I'd say happy Thursday.
And if you do have questions, obviously feel free to send them on.
Absolutely.
Yeah, thanks, Bill. It's been a great first webinar, and thank you everybody for joining. I think hopefully you found it interesting and informative, and we're going to do this again. Hopefully you can join for that as well.